Hi class 8 students, I hope everyone is doing well. So this is our lesson number 6 of the chapter Light. Here our first topic is about myopia. Now let us see eye defects. So first one is myopia, that is nearsightedness, and the second one is hypermetropia, that is farsightedness. Now let us discuss about myopia. This is a faraway object and this is a nearby object. Now see, this is patient view. As you can see here, the patient can see the nearby objects clearly, but they cannot see the faraway objects clearly, and it seems to be blurry. Okay, now see here in normal eye, this is how the image forms on the retina. Now let us see in defected eye. So this defect may arise due to elongation of the eyeball. So this myopia, it may arise due to the elongation of the eyeball. So the light rays from a distant object arriving at the eye lens get converged at a point in front of the retina. Now as you can see here, the light coming from a distant object arriving at the eye lens. Now then the rays, it gets converted at a point in front of the retina. At this point the rays, it gets converged. Can you see it? And the image on the retina, it becomes unclear. Now see the correction. This defect can be corrected by using a concave lens of appropriate focal length. Now by using a concave lens of appropriate focal length, this myopia can be corrected. Alright, now in case of myopia, nearby objects are clear, whereas faraway objects are unclear. Now see, this is how the image forms on the retina in a normal eye. Now in case of defected eye, the light rays from a distant object gets converted at a point in front of the retina. So in case of defected eye, the light rays which is coming from a distant object, they get converged at a point in front of the retina, and here the image forms on the retina is very unclear. So this defect may arise due to elongation of the eyeball and excessive curvature of the cornea. So this myopia, it may arise due to the first one is elongation of the eyeball and excessive curvature of the cornea. This defect can be corrected by using a concave lens of appropriate focal length. Now by using a concave lens of appropriate focal length, this myopia can be corrected. Alright everyone. Now let us discuss about hypermetropia. So see here, this is a faraway object and this is a nearby object, and this is the patient view. As you can see here, the patient cannot see the nearby objects clearly, but they can see the faraway object clearly. This is just the opposite of myopia, right? So see here, this is a nearby object and this is how the image forms on the retina in case of normal eye. But in case of defected eye, so this defect may arise due to shortening of the eyeball. As I already told you, hypermetropia is just the opposite of myopia. So in myopia, the defect arises due to the elongation of the eyeball, whereas in case of hypermetropia, the defect arises due to the shortening of the eyeball. The light rays from a nearby object arriving at the eye lens get converged at a point behind the retina. Now as you can see here, this is a nearby object, and the light rays from a nearby object which is arriving at the eye lens, they get converged at a point behind the retina. So retina is present here, and the light rays, they converge at a point which is behind the retina. So correction for hypermetropia is by using a convex lens of appropriate focal length. So by using a convex lens of appropriate focal length, this hypermetropia can be corrected. Now see, in case of hypermetropia, the faraway objects are unclear, whereas the nearby objects are clear. Okay, now see here in normal eye, this is how the image forms on the retina in case of hypermetropia. The light rays from a nearby object arriving at the eye lens get converged at a point behind the retina. This defect may arise due to the focal length of eye lens becoming too large and eyeball getting shortened. Okay, now see here, this is defected eye, and this is how the image forms on the retina in case of hypermetropia, where the light rays from a nearby object that is arriving at the eye lens, it get converged at a point behind the retina. Can you see here? Now, this defect can be corrected by using a convex lens of appropriate focal length. So, by using a proper focal length of a convex lens, this defect can be corrected. Now, next we will see cataract. It leads to decrease or loss of vision of the eye. A cataract develops when the lens in our eye, which is normally clear, it becomes foggy and it blocks the light as it passes through the lens, and as a result our vision becomes blurred. Now see here, this is normal vision and this is a person having cataract. Alright, so in normal eye the lens is clear, so it has got normalized lens, but in case of cataract it has cloudy lens. So cataract, where clouding of the lens in the eye that affects vision. Can you see the lens? It seems to be very cloudy. The crystalline lens of some people in old age becomes hazy or even cloudy. Now the lens is a crystalline, so the crystalline lens of some people in their old age it becomes hazy or even cloudy. This happens because of the development of a membrane over it. Now this happens because there is a development of a membrane over the lens. Alright. Now it is possible to restore the vision by replacing the opaque lens with a new artificial lens. Now this cataract can be treated by restoring the vision by replacing the opaque lens with a new artificial lens. Alright, so we are done for lesson number 6. Thank you, students.